He's the gentleman who's responsible for the McPherson report, which is a very great report, and I'm sure he'll be talking a little bit about it.
I'll go as quickly as I can. I've got a bunch of slides, and what I want to do is lead you through some facts about wind turbine noise, especially low-frequency noise, and what I do as an acoustician to help educate communities, developers, planners about how to design to prevent community noise complaints. So who am I? I've been working in acoustics over 30 years. I'm a member of the Institute of Noise Control Engineering since 1993 and actually joined as an associate in 82. 10 years industrial power plant design and noise control. My basic method is to promote good acoustic neighbor policies, and for the last 3.5 years I've been investing wind turbine noise independent of wind industry. And I've suffered the same adverse health effects as those reported by people living near wind turbines, including nausea, dizziness, inability to concentrate. And this is with my colleague Steve Ambrose, who is arguably 50% responsible for the Bruce McPherson study. So, we're each 100% responsible for it. My motivation is to hold paramount the safety, health, and welfare of the public. That's a canon of ethics for NC members and licensed professional engineers. And I think what we'll do is maybe we'll make a set of these slides available so people can have these to look at later. I'm going to go through a lot of stuff pretty fast, and so you'd also be welcome to contact me if you have questions. So we'll have questions after this, maybe if I can get it through this fast enough. My design basis is health. Not only do I want to minimize noise, I actually want people to feel good. And this is actually embedded in the word welfare. Welfare actually means well-being. So that doesn't mean, well, we're kind of coping or getting along. We're actually feeling vital. So the World Health Organization says we want to consider annoyance or high-level annoyance as an environmental health burden. This is something we want to avoid. And because annoyance is often confusing for people, especially in the United States, we tend to think of it as a kind of a small problem, but actually annoyance is a big problem. When you're annoyed, your activity that you're involved in is being interfered with. And so that represents what I like to call disturbance. Disturbance is also used by researchers in Europe to describe interference with activities, including sleep. In general, we say noise is unwanted sound. So we can distinguish between an industrial sound and, let's say, surf or wind in the trees, because those natural sounds don't tend to disturb most people. However, industrial noise does tend to disturb people because it has a peculiar character. And does the wind turbine noise disturb and sicken people? Some people living nearby will, yes, indeed, when they're too close. And we've known this for some time. This has been now being investigated by physicians, and rightly so, because it's a health issue. And in short, as summarized by Hanning and Evans, shortly after wind turbines began to be erected too close to housing, complaints emerged of adverse effects on health. Sleep disturbance was the main complaint. You're going to see a theme in what I'm telling you. This is a health problem. As an acoustician, I can come in and investigate and say, well, we're seeing these dBs, we're seeing this sort of character sound signature, but over and over again, I'm going to tell you this is a health problem, and it needs to be investigated by physicians. So again, in 2004, Pedersen and Way found a good percentage of the population reporting disturbed sleep when noise levels exceeded 35 dBA outdoors. And you should note that these were for turbines that are very small compared to the turbines that are being installed now. These are turbines in the 150 to 600 kilowatt range. Hanning and Evans again indicated that reports that are being dismissed by some as being subjective or anecdotal, those dismissals may be premature because health experts contend that the complaints constitute epidemiological evidence of a strong link between wind turbine noise, ill health, and disruption of sleep. We also now know in the legal framework from the Ontario case of February 2011 before the Environmental Review Tribunal in Ontario that on the legal framework, wind turbines do cause harm if they're placed too close. Although the case was dismissed under certain legal conditions, the tribunal found that the evidence presented demonstrates that wind turbines can produce harm if they're placed too close to residents. And so the debate has now evolved to one of degree. So the question arises, what distance is unsafe? Nissenbaum and colleagues, Armenia and Henning, issued a professional caution in 2011 based on preliminary evidence which indicated that sleep and health is affected nearby from wind turbine noise. And they issued a report which was just published just under 2 weeks ago, a week ago Monday, called The Effects of Industrial Wind Turbine Noise on Sleep and Health, which essentially constitutes proof, epidemiologically speaking, that health is disrupted within 1.5 kilometers. So what is going on with large wind turbines? Well, they're very large, they are high, so and they have to be exposed to wind, which is the fuel, in order to produce electric power. This graphic was produced by Mark Boswell of the Star Tribune, and he used as sources American and Canadian wind energy associations. So all of this information came from them, and as I understand it. And so the turbines produce a pulsating sound. They produce a repetitive pressure as the blades rotate high to low. And they do produce low-frequency sound, which I'll show you in a couple of slides. And the low-frequency sounds penetrate walls and windows in homes, which are sensed as vibrations and pressure changes. If you stand underneath a wind turbine, you won't hear what you hear a half a mile, 2 miles, 3 miles away. This graph is from our Steve and my study at Falmouth. This shows the pulsatility or periodicity, which is not seen in the A-weighted sound level. I'm going to see if I can get my, there we go. I've got a virtual laser pointer here. So this is the A-weighted sound level outdoors when we get safe. Low 40s, sometimes pulsing up a little higher. But this is not the kind of sound level that we would normally associate with sickness. In transportation noise, this is a fairly benign sort of a sound level. Definitely audible, but nothing we would write home about. But in this case, this was wind turbine sound level, and we were sick. Steve had headache, inability to concentrate. I was nauseous. I had difficulty thinking. But when you take the A-weighted filter off and look at the total signal, which the ear does respond to based on how its salts work, we're seeing very strong pulsations, which are not revealed in the A-weighted sound level. This is a time series graph showing, summarizing what happened to us when we studied in Falmouth. We arrived at the site, we were healthy. Within a very short period of time, roughly 20 minutes, half hour, we started to feel debilitated. We had the symptoms that we reported in our study, irritability, headache, nausea, and so forth, very quickly. Over here, we've got the kilowatt output of the turbine, the scale for that, and those are these dots here. The turbine's operating at its rated power. In other words, what it was permitted for. And we were sick at about 520 meters away. Over the course of the next few hours, the wind speed died, and we decided to go outdoors and measure. We felt a little better once we got outdoors, and there was very little turbine operation during the night, and we slept okay. But then the next morning, we felt bad. We went away and achieved some reduction in our health symptoms. When we went back to the site, we immediately felt sick again. We stayed there and did more measurements. Then we went away again and felt better. And then we came back, and our sleep was interrupted during the night. We slept fitfully And the turbine was operating and producing some degree of power, almost up to full power. And the next day we left the site. So this kind of series constitutes what I understand is called a case series, where we get these repeating differences in health over time related to some sort of operation. People have asked me, well, you know, surf makes infrasound, the wind makes infrasound, so what's going on? Well, I just made this chart this morning for you guys, and this is a comparison of the signal that we found indoors at the home in Falmouth when we were sick. And you can see the pulsatility of the signal coming from the wind turbine. Very strong pulse, about 1.4 seconds apart. And this is the recording I did of surf indoors in October. These scales are the same, and these both time and amplitude are the same. But the surf comes about 9-10 seconds apart. It's quite strong, just as strong or stronger than the wind turbines, but it has no health effect at all. I felt great. I loved the sound of the surf, and I slept well. This was occurring over a period of several days. So something is going on with this signal that this signal does not produce. We know that the wind turbine low frequency noise carries with a slower rate of drop than the so-called A-weighted sound level. This is all pretty technical stuff, but it basically means the low frequencies carry longer and farther than the noise level measured by the A-weighting filter. And the A-weighting filter is what's used in most regulations. So it tends to hide what's going on with wind turbines. Muller and Pedersen documented that the spectrum of wind turbine noise is actually moving down in frequency as the wind turbines are getting larger. And they are getting larger, getting much larger. You've probably heard the recent reports in Vermont of strong complaints out some 3.5 miles from the newly installed 3 megawatt turbines. This is the frequency spectrum for the 3 megawatt turbines that are just being installed and operating in Vermont, the V112s, and there's a large amount of low frequency noise in these larger turbines. The bulk of the energy, some 100 times more energy, is located below 100 hertz. Down below, say, 20 hertz, this is where some of the largest amounts of energy are shown. And these levels are from the manufacturer's tests. This slide shows an assessment of the presence of low frequency and noise, which would be annoying or intolerable to people inside homes, done by a Muller in reference to the Maastricht V112 facility. He just produced this report this year. And basically it shows the presence of low frequency noise as assessed using the Danish standard, which measures the A-weighted sound level from 10 hertz to 160 hertz, which is all low frequency. It disregards everything else above that, out to some 1.5 kilometers. Earlier this year, I was out on Nantucket Island, and I measured or assessed the low frequency noise emissions from a 100 kilowatt turbine, a very small turbine compared to the large ones that are associated with a lot of the problems that we're hearing reports about. This was measured indoors in a home several hundred feet away from this small 100 kilowatt turbine on Nantucket Island, which was erected at the local high school. Interestingly, this was erected on the high school playgrounds. There's no safety setback for that turbine. But at several hundred feet, we've got very strong pulsations coming from this small turbine. The Danish low frequency noise limit places an indoor noise limit of 20 dBA maximum on the average sound level. But as we know, people's hearing we don't take time to compute the average sound level and then decide if we're annoyed or not. Our ear is responding continuously to the peaks in the sound. And the peaks here are coming up as high as 30 dBA. This is the low frequency A-weighted sound level. And these people have issued appeals to stop the noise, out to some 900 to 1,000 feet from this very small turbine. A lot of reports indicate that if the noise level or the average computed sound level is below the hearing threshold, that people won't hear it. Well, that's just not true. In fact, Malcolm Swimbig cites in his Inner Noise paper of this year, cites Japanese research which shows that people are quite capable of hearing low-frequency industrial wind turbine noise far below the hearing threshold. So I just put this slide up as an indicator that we all know from our common sense is now emerging in scientific research. Is wind turbine noise low-frequency impact, is this unique? Well, actually, in acoustics, it's not. We know of sick building syndrome dating back to the 1970s, the Ford building, related to symptoms exactly the same as even I and of course, everyone around who are complaining around large wind turbine sites. Same symptoms have been documented going back to the 1970s. So the response of the human physiology to pressure pulsations inside has been occurring for some time, but in a limited context. For some buildings where there's been a problem with ventilation, ductwork, this has surfaced, but again, it's been a fairly isolated cases over time, well known for us in the acoustics industry, but not well known generally. Now we have this proliferation of large machines capable, apparently, of producing the same effects outdoors and inside buildings when they're placed too close. Mr. Leventhal is arguably a well-recognized expert in low-frequency noise, acknowledges that people will adapt protective strategies if they are annoyed by low-frequency noise. And they may include sleeping in their garage, or they may abandon their home in order to get sleep. So to recap, wind turbines definitely create complaints and disturb sleep and can cause harm if placed too close to homes. Low-frequency noise is involved by self-reporting and also by examination of field noise emissions and the manufacturer's tests. And people will adopt strategies to take care of themselves if they need to. So why not just quiet wind turbines using industrial noise control options so they can be put anywhere? Well, after examination over the last few years of wind turbine noise emissions, what Steve and I have found so far is there's only one option, which is distance. And if sufficient distance is not used during siting, planning, and permitting, once wind turbines are built, if there are complaints, we only find that shutdown or removal will mitigate the problems. So as acousticians and for planners, can you use or design criteria? Those would be things like appropriate distance or noise levels to prevent adverse impacts. Well, yes, there are a whole series of standard tools which we've used over the decades to build criteria to prevent adverse impacts. And these include recognized standards on community response, case studies from the EPA, WHO guidelines, which are based on transportation and need to be adjusted for wind turbine noise. We look at disturbance and noise studies from wind turbines, and we also look at the epidemiological evidence, such as the recent Nissenbaum and Associates study. ISO community response is well known. When intrusive noise comes in over the background noise, and it is stronger than the background noise, community response escalates accordingly. We know from EPA case studies, when adjusted using the EPA method to account for the community and the character of the sound, that we can very easily predict what the complaints will be, but depending on the noise level of the incoming noise, the intrusive noise. Generally, what we're looking at is if we're designing for no reaction, we're down in the range of 30 dBA or so. If we want to design for widespread complaints, we'll design to levels in the range of 40, perhaps 45. Note that a lot of noise regulation use at nighttime of 45, inappropriately applying the EPA 55-45 guidelines, which were designed to protect people from hearing loss, and with a nod to speech interference and sleep interference from the early 1970s. Recent health information from the WHO shows that health effects start at 30 and ramp up to 40. Above 40, we have clear evidence of adverse health effects. So a lot of regulations are now outdated. These categories of observed health effects were not built on wind turbine noise. Wind turbine noise is not included in these assessments. And in fact, the WHO makes cautions if there are low-frequency noise or pulsating character, certainly the low-frequency noise, they make cautions about using these. And we do see, in fact, high noise disturbance for wind turbine noise. If we look at the Pedersen detailed assessment from 2009, about the only noise source they reviewed that was more annoying and more disturbing than wind turbines was shunting yards, where you have rail cars being banged as they're joined and decoupled and so on. That's a very annoying noise if you've ever heard it. And wind turbine noise is much more annoying than transportation. And typically you're looking at roughly a 10, in broad strokes, roughly a 10 dB offset to get to transportation noise. This is a slide adapted with permission from study by Nissenbaum et al. This shows the clear evidence of poor sleep within their caution was roughly 1.5 kilometers from 2010-2011. Clear evidence of poor sleep within that range, and that was for 1.5 megawatt turbines, for the GE 1.5s. And interestingly, they found a clear progression going out even into their control group, which is out in here. So they said even out in here, they're seeing evidence of worsened sleep, although it's less, less of a change from what you would consider normal or a good sleep condition, which would be below 5. They saw clear evidence of ramping even out in their control group, which is some as far as 6.5, 7,000 meters out. I've done a noise criteria reference chart with Steve for you to look at. We did this last year. This is a combination of 3 sets of criteria bases. It's basically this is a confluence of 3 ways of looking at what sound levels will produce. So at a sound level of 30, we have basically no reaction based on the case studies of the EPA. We have really no annoyance or disturbance from the 2004 Pedersen Way data, and we have no observed effects from the WHO based on transportation noise. When you get up to 40 dBA, you've got observed effects emerging from the WHO for transportation noise. You've got a large percentage of the population highly annoyed in the Pedersen data, and you've got widespread complaints from the adjusted EPA or normalized EPA case studies. So this provides some guidance for planners, developers, even promoters to understand what will happen with wind turbine noise in quiet rural areas. I'll just throw up the slide for the precautionary principle because we are still in the emerging stages of understanding what large industrial wind turbines are capable of inducing in communities when they're sited too close to homes. Take care. Exercise caution. We also have evidence that even officials who are promoting wind turbines can change their minds. An example is Mr. Simon Ramsey, who was a local champion of wind energy and even obtained permits for large industrial wind turbines on a parcel of his own land. However, in early 2012, I understand he did an about face and he started campaigning against wind turbines, according to newspaper reports, for which he previously held permits. And he has sought, through his connections, a string of concessions, again, I understand, including that the company scrap all turbines within 2 kilometers of his home.
Hey, Rob, this is Dave. We're running out of time. Could you just wrap it up?
This is a self-reporting in Falmouth at 430 meters from the nearest turbine. Yeah, there are 3 turbines operating there, and this is from a self-reporting diary, and clearly this is what happens when they're placed too close.
Well, Rob, I really want to appreciate you joining us today and presenting.
Thank you. This is just my last slide.
Okay, I'm sorry.
Information and use design safety margins to avoid adverse community reactions. As an acoustician, I suggest, based on the research the last 3 years, 30 to 33 dBA tops and 2 kilometer minimum. Thank you very much.
Thank you very much. You've really put on a great presentation, and we all thank you.
You're very welcome.